Okay, this video is going to highlight how to factor something that we call a perfect square trinomial. So first of all, what does that mean? Well, first of all, it's a trinomial. If you recall from earlier videos or earlier learnings in algebra, a trinomial means it has three terms. So a quadratic trinomial is something that most individuals are perhaps more familiar with, something that looks like ax squared plus bx plus c, where a, b, and c are coefficients and the variable is x. You can have a perfect square trinomial that doesn't follow the format of a quadratic, but maybe looks more like it's quadratic-like. And quadratic-like, if you recall, again, it's still a trinomial, and we have the coefficient here, but when you look at that middle term, perhaps it's not an x like the traditional quadratic above. But if the variable in the middle term, if you square that, and that is the variable that we see here, then that means it's quadratic-like. So if you hadn't picked up that pattern before, that's what a quadratic, the general quadratic looks like. We have the variable x in the middle term, and when you square that, that's the variable here in the first term. So if you follow that pattern for a trinomial, you can have something that looks quadratic-like. And so I just want to call that out because I'm going to demonstrate some examples of perfect square trinomials that are all quadratics, but we could apply that same principle to something that was quadratic-like if we wanted to. So what is a perfect square trinomial? It's a trinomial that follows a very specific pattern, and there are actually two different cases. I have those highlighted here. The only difference between these two cases is the presence of a negative sign. And so we can see that if you have a quadratic that follows the pattern a squared plus 2 times a times b plus b squared, that's a very special trinomial, and instead of utilizing traditional factoring techniques, which you could do if you wanted, if you recognize this pattern, you can actually factor it using the formula. And perfect square trinomial comes from the term this trinomial actually can factor into the square of a binomial, so it's a perfect square of a binomial. And again, the only difference between these two cases here is the presence of this negative sign. So notice we have a squared in both places and a b squared in both places and the 2ab. However, we have the positive 2ab in the one case and the negative 2ab in the second case. And all that results in is when you look at the factorization is a positive sign between the a and b in case 1 and a negative sign between for case 2. Okay, so how do you recognize the pattern? The best approach I believe is to look at your trinomial, and following traditional factoring techniques, you do want to make sure that your polynomials in descending order, highest powers of exponent on down, and pull out a GCF. When you look at both of these examples, A and B, they are both in descending order and there's not a GCF. So we would then move to the next step of factoring, which would say they're trinomials. And this is where you can make the decision to say, I wonder if they are perfect square trinomials. If they are, we can factor them using these formulas. If they're not, we'll go use a traditional factoring technique like the AC method, or if it was a go solve me problem with an equal sign, we can go use the quadratic formula if we wanted. Okay, so what makes a perfect square trinomial? The first thing is you look at the first and the last terms. Are they perfect squares? If they're perfect squares, we have a chance that this could be a perfect square trinomial. And so it's worth looking further. If this first and last term are not perfect squares, then it's not, and no need to progress. Just go use a different factoring method. So if you notice here, x squared, that is a perfect square. And you can say, well, the perfect square of what? So that's actually, it's an x that has been squared, okay? So an x is what was squared there. And this third term, that's a 5 that's been squared. So is this a perfect square trinomial? Well, if you take what's been squared in each case, and if you multiply that together, I'm going to put the coefficient first. So if I multiply 5 times x, if you double that, okay, we're going to double that. And if we compute that math, we get 10x. If you follow that process. If that term is what is sitting here, then it is indeed a perfect square trinomial, and we can use the formula to do the factorization. Again, if there was a positive sign here, like there is, we'll use this formula. If there's a negative sign there, then we would use the other formula. So how would I write that out in factored form? This will be my A. That is what has been squared there. The 5, that's my B. That's what has been squared there. And if I multiply them together and double it, that's what's in the middle, perfect square trinomial, which means you literally can just factor it like this. You put A, which happens to be an X. This one was positive, so I have a plus sign. The B was 5, and I write it as a square. Another way to write it, which is also acceptable, is to just show that it's that same binomial times itself. So this is an example of perfect square trinomial. Let's do this second example. If I look again, descending order GCF, yes, these are also both perfect squares. You say perfect squares of what? Well, here I have a number and a letter that have been squared. So this is actually 2p. If I square the 2p, I get 2p times 2p, which would be the 4p squared. So that is a perfect square of that expression right there. And 49, that is also a perfect square of 7. You could think about it as the square root of 49 is 7, or 7 squared is 49. And if I take these two, and if I multiply them together, 2p times 7, and if I double that, is that what is sitting in the middle? So 2 times 2 is 4, 4 times 7 is 28, and I have the p. So indeed, this is what is sitting in the middle here. So it is a perfect square trinomial, which means this 2p would be the A, 7, that's the B, and because this has a negative sign here, I will follow this formula for the factorization. So it will be A, which is 2p, minus, and then the 7, and then square it. And again, you could choose to write it like this if you wanted to do the binomial times the binomial. Okay, so two other quick examples. Let me let you see that. Okay, two other quick examples. This problem, again, it is in descending order. A quick peek says I cannot pull out a GCF. If you look at this, 16, that is a perfect square. It's a perfect square of 4. But this is not a perfect square. So if you took the square root of this, you would end up with this expression, the square root of 3 times x. And when we talk about perfect squares, we want to see a rational number here, which means it's a whole number or a fraction. I don't want to see radicals. So this is not a perfect square trinomial, which means I'm not going to factor it that way, and I would go use a traditional method. Let's say perhaps I'm going to go use the AC method, or I could try trial and error, complete the square method. There's a variety of options. Okay, but let's look at this one. If I recognize that this is a trinomial and I jump right in and I want to say, is this a perfect square trinomial? 24 is not a perfect square, and neither is 6x squared. And so if you jump to that rash decision and decide to go do this using an alternate factoring method, you will get the correct answer, but you just unnecessarily cause yourself some extra work. Because remember, factoring says make sure that you're in descending order and pull out a GCF if you can. And I notice I can pull a 6 out of all of these. So if I factor out that 6, which is the same as if I were to divide each of these terms by 6 and then leave what remains, there's an x squared in the first term. If I divide that by 6, I'm left with 4x. And if I divide that by 6, I'm left with 4. So if you take the opportunity to pull out that GCF, you realize that this is now the trinomial that you want to go factor. And the 6 will hang along for the ride. But this is indeed a perfect square trinomial because this is an x that has been squared. I think I need a new purple crayon. This is a 2 that has been squared. And sure enough, if I multiply them by each other and double it, I get 4x, which is what is sitting there in the middle. Okay, so this is what's here. It is a perfect square trinomial, which means this would be the A, the 2 would be the B, and if you recall the formula, because this is a plus sign, I end up with the A, which is x, plus the B, which is 2, and I can square that. And don't forget that we did pull out this 6 as a GCF, so that is still there out front. So this would be the answer to the factorization, which you could also, again, write that as that same binomial multiplied by itself. So that's it. So those are perfect square trinomials. Again, there are trinomials, a lot of them, that are not perfect squares, and we're going to use a traditional method. But even if a trinomial is a perfect square and can be factored utilizing these two formulas, you don't have to do it that way. If you don't notice that it's the perfect square trinomial, traditional factoring method, as long as the trinomial factors, a traditional method will result in the same answer.